It'll be
Yeah.
okay. So you all have been told we're recording our meeting. And this is February the 7th, 2026, and a very important topic, an issue that is generating a lot of press in many places because of the extreme environmental demands of these AI uh, processing centers. So our honored guest, Tosi Adegbija, has been active in trying to mitigate a lot of the problems. He's very good. He's a real cutting edge scientist researcher on innovations and of technology, but he's not a booster. There's a difference. I would say he's half critic. So what he does is he uses it, he studies it, and he has many awards that you can go back to his description to see. He's a distinguished professor. But he also tries to foresee and mitigate the damage that new technology does as it's coming in. And that's why we are so honored and pleased to have him speak. And I hope that I did justice to you, Tosi. And I will just, at this point, turn it over to you and your slideshow.
That was very kind. Thank you, Gloria. So it's good to be here again. I'll go ahead and share my slides. Can you all see the slides?
I can.
Okay. So it's good to be back. Like Gloria says, I think a lot about AI and get mad a lot of times about some of the hyperbole around AI and the ways in which a lot of tech people talk about artificial intelligence. In my previous conversations with this group, I think I've talked quite a bit about what AI is. And one of my pet peeves is, the use of the term AI. I think, first of all, intelligence is a little bit of a misnomer. But then AI is commonly used as a broad term. Recently, what most people mean when they say AI is large language models specifically, but then AI is the broad term for machine learning and large language models and so on. And the focus of my work is on, uh, I work in the hardware space, but on energy efficient AI. And I'll talk a little bit more about that later. But then the general idea is we're trying to learn more from the human brain and apply some of the ideas for efficiency from the brain into hardware, computing hardware in general, and then specifically for AI applications. But one of my favorite pastimes is, keeping track of some of the crazy things that AI billionaires say. So this is one good one from not very long ago. Elon Musk says that in 10 to 20 years, work will be optional and money will be irrelevant thanks to AI and robotics. Most people know not to pay much attention to anything Elon Musk says, but then this is, an interesting example of the grandiose statements from AI billionaires. Another interesting one is from Zuckerberg. Most of your friends will be AI. This was from last year. He said that on a podcast. Um, and more recently, one that I found interesting was from some Altman. He says caring for a baby is now impossible without ChatGPT. And so, I'm impressed by the lack of self-awareness that would make a person publicly announce themselves to be such a massive loser. But then, even though this seems like weaponized stupidity, I think that there's a method to the madness. Um, AI companies have struggled, as Gloria was saying. A lot of people are more concerned about AI than optimistic about AI. And so they're struggling with making AI as broadly palatable as it is to tech people, to the average person, to the non-tech person. And most people would, balk at the amount of money they are spending on building data centers or the impact of the data centers on our communities. And so making pronouncements like this is how they hope to mitigate the shock of the price of continuing to develop the AI models. And so you're less likely to get mad at the idea of spending more money on your electricity bill because of a data center if you think that that the necessities like raising a child are now impossible without AI. Um, like I've said several times, they're not to be taken seriously, or they should be taken seriously, depending on your perspective. But I think most tech billionaires have this sinister motive. They're trying to maintain the hype, so that their companies can maintain high valuation, and so that society will not turn against the quote unquote advancement in AI. And just to give some context for what is behind the hype, the requirements for developing or continuing to develop AI involves building lots of data centers. That's probably the biggest news we have now. There's, you've probably heard of the circular deals around NVIDIA and OpenAI and Oracle, and they're spending hundreds of billions of dollars because data centers are very expensive. So the study from the International Energy Agency showed that data centers globally consumed about 1.5% of global electricity in 2024, which is more than the amount of electricity that Saudi Arabia consumes, so more than a country. And that the projection is that this will continue to increase. They expect an annual growth rate of about 12% in electricity. And the truth is that compared to other industries, AI doesn't consume as much energy as a lot of other industries. Same thing with water as well, for example. The problem is that the data centers are usually not built in isolation. So usually when they find a strategic location, they don't just build one data center in that location. They build multiple data centers in communities. So for example, Virginia has more than 600 data centers in just the one state of Virginia, right? And there's a bunch of reasons for that. So tax incentives, fiber optic infrastructure, inexpensive power, or proximity to water and other resources. And once they build one data center, there's a chance that they'll try to build a lot more. It's also easier to communicate between the data centers when they're in close proximity. And what that means is there's a direct impact on the communities that these data centers are built on. Typically, the electricity grid, the electric grid needs to be upgraded with new power plants, transmission lines, new substations to meet the demands. And the cost of upgrades is usually passed on to the residential ratepayers in those communities. And the increase in data centers leads to increases in wholesale costs, grid congestion, and cost subsidies for the data centers or for the AI companies that are usually burdened on or put on the residential users of the electricity. There's been some studies, one by Bloomberg News, that showed that electricity costs increased for areas near data centers by as much as 267%. So almost 3 times the cost of electricity for the residents just because of the presence of data centers in those communities. And this trend is just getting worse, right? They're building more data centers. This is some analysis from April of last year. More data centers are being built, and the expectation is a doubling in 6 years, which is a much faster growth than most other sectors. I alluded to this before. The caveat is that the energy consumption of data centers is still more modest than a lot of other domains. So this is an example of other industries and how much energy data centers consume. And it doesn't look like much. The problem is the impact on individualized communities. This is from the IEA data as well. So a lot of the conversation is about the cost of training data centers, but then I'm sorry, cost of training AI. But then the real cost of AI is in the inference. So the first step for AI is to train the models, which consume thousands of GPU and lots of power consumption. The problem is what is below the water, the iceberg below the water. That's the inference, the continuous cost of AI. So when you make an AI query, for example, that consumes energy. And typically the way that happens is that you type on your computer and the query goes to the cloud in quotes. That is the data centers that are being built. And, they're trying to build more data centers to sustain this inference cost. The good news is that things have gotten better. The resources have gotten more efficient over the years. The last time I spoke with this group, I believe I mentioned this statistic that a ChatGPT query cost about 10 times the energy of a Google search. Right. But over the years, ChatGPT and most large language models have gotten more efficient. And now a ChatGPT query costs about the same as a query from a Google search. Now, that's great news. The problem is described by Jevons paradox. And the idea here is that when you increase the efficiency of a resource, it often leads to higher total consumption than savings. So as the technology makes resources cheaper, the demands actually increase, and that fuels greater consumption. So for example, more fuel efficient cars might lead to more driving. And in the same way, more efficient AI reduces cost, but then increases the usage of AI. And as a result, what we end up having is an overall increase in the energy demand in data centers. And the point here is that it's not just enough to make them more efficient. That's one of the things that I focus on. But then we also need to limit the demand for the resources and create systemic shifts that move away from models that solely prioritize throughput. There's also been a lot of talk about the water consumption of AI. And the truth is that in general, there's been a lot of studies about this. AI doesn't consume more water than other industries. The problem is the localized impact of AI on communities where the data centers are built. Like I said before, data centers tend to be built in clusters. And if a data center is built in your city, some of us live in Tucson, there's likely to be more data centers built because it's easier for the companies to utilize the resources and communicate more effectively between the data centers. And most discussions about water focus on the amount of water used, but then there are other factors that can affect the communities. So there's potential strain on the water source, where you create more competition for water during dry spells, for example. There's the potential for increased pollution from evaporative cooling processes. So a lot of cooling in data centers involve a fair amount of evaporation that might leave behind high concentrations of contaminants and salts. The infrastructure gets stressed. And the point of this is that even though at a grand scale, AI might not consume more water than other industries, it still has a potentially very negative impact on communities where AI is, where data centers are built. So my argument is that one of the biggest problems is that we are not using the right tool for the job. Like I said before, AI in common parlance usually refers to large language models. And these large language models are called large language models because they have potentially trillions of parameters. So the parameters are the internal numerical values that the model automatically learns and adjusts from its training data to make predictions. So essentially, simply put, the parameters allow a model to store more knowledge, and it helps the model to recognize complex patterns and achieve better accuracy. And the conventional wisdom for large language models is that the bigger the model, bigger meaning more parameters, more data, trained on more data, the more intelligent the model is. The problem is that when I go on ChatGPT and make a query, say, what is the capital of France, for example, I'm using the same model that has been trained on organic chemistry and computer architecture and physics. So you're using this large model to solve a very small problem. And a lot of companies are being built. I was telling Gloria before we started recording that I had a meeting with a lawyer from New York yesterday, and he was talking about how many companies in the legal space are being, pitched to them every day. And a lot of these companies use large language models for trying to do something specific in the legal space. And what we're doing here, it's equivalent to killing a bug with a shotgun. We're using the wrong tool for the job. And even if you succeed in killing the bug, you're more likely to cause more destruction than what killing the bug was worth. In the worst case, you potentially harm other people. So one of the reasons for so like I said, first, big picture problems that we're using the wrong tools for the job. One of the reasons for that is the hardware that underlines a lot of AI today, a lot of machine learning, is based on the GPU, which is a very powerful computer, but then it's very inefficient. It consumes a lot of power. It's notorious for that. And even though over the years, companies like NVIDIA and AMD are building more efficient GPUs, they still consume lots of power. So the H100 GPU, for example, consumes up to 700 watts per chip. One of the reasons for that is the von Neumann paradigm, which was invented in 1945. And the idea here is that you have a separation between the processor and the memory. And so if you're trying to perform some computation, for example, you need to move data from the memory to the processor, perform the computation, and then move the data back, the solution back to the memory. And that transfer of data between processor and computer, and by the way, that's how all your computers are designed. Your laptops and desktops and mobile phones all have separate processor and memory. That's a fundamentally inefficient model for computation because the communication of data consumes a lot of energy, and in some cases consumes even more energy than the actual processing of data. So that's a problem that we're trying to solve. Like I said, the GPU paradigm is powerful but inefficient, optimized for throughput, not sparsity. Sparsity means that there's not always data to compute, right? But then the GPUs are built to perform as many computations as possible at any given time per second. And the GPUs keep processing every clock cycle, whether information changes or not. So that would be equivalent to your engine running at 500 revolutions per minute at a stoplight. So essentially, we're wasting energy. So my argument is that the right approach to solving what seems like an intractable problem isn't building more nuclear power stations or even building data centers in space, as Elon Musk is trying to do, as well as other companies like Google. But then we need to rethink how we deploy AI. And this is not a revolutionary idea. I think a lot of people would agree to this who are not fully bought into the AI large language model hype. The first step is right sizing the software. And what that means is not using a large language model when you need a small machine learning model. So, for example, not using a large language model when you have a tool that is meant for summarizing text, right? The second approach is using a different paradigm of hardware for computing AI models. And I'll talk very briefly about this. I won't go into any low-level technical details, but then just to give you an idea of what is out there for solving these problems. And I think these go hand in hand, the idea of right-sizing the software and rethinking the hardware. The more efficient hardware would only work if the software execution characteristics match the hardware resources. And so this involves a co-design process between hardware and software. So the first approach is what I call context-specific AI. And the idea here, so for example, you're trying to summarize text. This is an example I use a lot. And I do some work in this space in the legal field as well. You don't need the model to understand context for every kind of text, right? You can build something specific to medical text, for example, or use much fewer parameters, which means a much smaller model that will be as accurate as a large language model like ChatGPT or Google's Gemini, while being a lot more energy efficient than any of those models, right? So you can achieve the same goal. It's kind of like specialization. When you're a specialist, you're likely to be faster, you're likely to be more efficient at doing a task. And this involves fine-tuning small models for a specific task. There are other more technical approaches like retrieval augmented generation, or RAG, which involves using a small model plus a database that acts as some form of ground truth for the small model. So even though the small model doesn't have as much context as a large language model, it's able to perform as well or better than a large language model just because it has that external knowledge base. So for example, a company documents or databases that helps it to ground its responses before generating the response. So this also, reduces hallucination, which is one of the major problems with large language models. This approach has been used in different domains. It's not as much as I would love to see, but then there are lots of potential domains where this could be used in legal review, for example, rather than using a trillion parameter ChatGPT model. You can use a much smaller $3 to $7 billion parameter, 3 to 7 billion parameter model while achieving the same result as a much larger model. This can be used in the medical domain, in predictive maintenance, and so on. The second approach, the hardware approach, is inspired by the brain. So this is something I work on specifically, the idea of inspired by the brain, by the human brain, which consumes no more than 20 watts of power, versus supercomputers that consume megawatts of power. The brain, I always like to use the example of, when I'm speaking, I'm using my vision and my voice and my hands, and I'm doing so many things. It's an amazing processing system. It doesn't do it justice to call it a computer. But then the brain only consumes so much power. And we know there are a few reasons for that. One of the reasons for that is the fact that the brain doesn't have a separation between processing and memory, right? So you're not transferring data. That's one of many reasons. It's not the only reason. But then the idea for the second approach to mitigating the cost of AI is the idea of neuromorphic computing. Essentially, neuromorphic computing is computing that is built, inspired by the way the brain processes. And the three key principles to neuromorphic computing is locality. So that's going back to the earlier example, not separating the memory from the processing. So that'll be equivalent to, that separation is equivalent to going to the grocery store or walking to the grocery store every time you need something, right? If you build a kitchen in the grocery store, you'll cook much faster and use a lot less energy than people who have to go to the grocery store every time they need an ingredient. Of course, the problem with that is that that wouldn't work for everyone. And so it's usually context specific, it's usually application specific. The idea of sparsity is that you only compute when something changes, right? So we don't always need to perform computations if the input information hasn't changed. And so we leveraging that sparsity can be significant for saving energy in AI deployment. And the third one is asynchrony. This is where parts of the chip, all the parts of the chip don't have to be working at the same time. You can turn off parts of the chip that are not being used at the moment. And there's a lot of work being done in this domain. Intel's Loihi chip is an example of a neuromorphic computer that attempts to use these principles for improving the efficiency of AI. IBM True North is another example. Spinnaker, these are all chips that exist right now. Some of them are still in the research domain, but then I think future AI systems will leverage this a lot more. And there are real world use cases of this as well. So aerospace, automotive robotics, and a bunch of other such. NASA, for example, uses Loihi chips. And these chips can be up to 100 times more power efficient than traditional GPUs for processing AI applications. So there's still a lot of challenges, and this is just the very high level summary of what is happening, what some of the research going on, and how we can address the efficiency gap. But then there's a lot of challenges, the software gap. So programming spiky neural networks. I think I talked about spiky neural networks the last time I was here, but then spiky neural networks are the kinds of models that will work best for neuromorphic computing. They are more biologically plausible. They try to model the brain's approach to computing a lot more closely. And they are still very challenging. I was working on this week, struggling to get as close accuracy on spiky neural networks as you would to artificial neural networks, which is the traditional AI models. And so we need a lot more research and a lot more tricks to make these computing approaches match traditional machine learning AI approaches. And one of my ways of going about this is I interact with neuroscientists to try to understand the brain better and then find computing principles in the brain that are well understood by neuroscientists and try to find ways to implement those computing principles in hardware and in AI processing. So again, the ecosystem for more energy efficient AI computing is maturing. It's not mature. We have a very long way to go, but there's a lot of work going on in this domain. So the efficiency approaches all three levels. So the software, the right-sized models, the more efficient computing, neuromorphic in-memory computing, and then there's still the level of more efficient power sources. And the point I'm making in this talk is that it's not only about more efficient power sources, which is what most of the conversations from the AI billionaires are about. It's all about building more data centers and building more nuclear power plants or building data centers in space. And my argument is that we need to focus on all three levels of the stack, the cleaner energy, smarter hardware, and contextual AI models. So I don't think that we'll ever get rid of the cloud model for AI. And AI will continue to consume resources, but then the argument is that it doesn't have to destroy our environment. There's a better way to this. We can have a hybrid approach where we have a lot more specialized models with neuromorphic computing for application-specific deployment. while there might still be some cases where you have large GPU clusters and data centers for, the large language trillion parameter models. Whenever I talk to non-tech people about AI companies, one of the first things I say is, the tech billionaires are mostly full of shit. And so you shouldn't listen to everything they say, or you should listen to them and, take what they say with a grain of salt, because what they care about is maintaining their billions and maintaining the hype around the products they build. And so that goes to the first point here. The gap between the capability claims and the efficiency reality is very wide. At the same time, there's a lot of work being done. So I think, this is how to pragmatically look at the advancements of AI. There's a lot of work being done on rethinking the software deployment and the hardware architecture to make AI a lot more efficient. And we can pursue these approaches right now in minimizing the impact of AI on this, on the sustainability of our world. So that's all I got. As usual, I'd like to give time for conversations, any questions or comments. Thanks for your attention, and I'll take any questions right now.
Do we have any questions from the audience? I'm curious. I'll just fill in the blank time till I see some hands.
Yeah.
I'm curious, like what types of little small jobs, say that if you're a researcher in the humanities or something and you want to find an analysis of some novel, for instance, would that be suitable for this smaller model?
Yes. So the thing with the large models is that they are trained on, essentially they're trained on the internet, right? And so to do the analysis of your model, you don't need information about chemistry or physics, or computer architecture to do the analysis. Or you don't, if you're doing an analysis of a novel in English, you don't need knowledge of French and German, which these models are trained on. Right. So again, the challenge, the problem right now is that we don't have easily accessible small language models to do what you're asking for. So if you wanted to do that today, you would need to use one of the large language models, right? To achieve that small language model capability, you need to do a fair amount of fine tuning so that the small language model is able to understand the context for the summarization of the novel. And that involves a lot of technical know-how to do that right now.
I appreciate that answer, because that's a lot of what people do is searching text, whether in legal
right,
or other environmentalist groups, looking for certain texts and then getting the high points and analyzing them. I thank you for that. And I can see where it could be done, where you would just say, like with the not French, not Spanish, only English or whatever. Those are those rerouting. And I do see Alice Wittenberg raised her hand. Alice, do you have a question?
Yeah, hi, thanks. We might have two questions here, but my question, it has to do with Elon Musk. And I was really relieved to hear you say that he's mostly, not to be taken seriously, because when I heard him say that he wanted to put 1 million solar-powered data centers into space, I was terrified by that. I mean, is that possible? Is that anywhere near possible? And if it is possible, what would the consequences of that be?
So is it possible? Frankly, I don't know. I want to say yes. I think it is possible. Is it, so the other part of the question was, is it anywhere near possible? I don't think it's going to happen in the next few years, not in a very long time. And again, going back to what I said about Elon Musk, he is known for making, grandiose pronouncements, and in general, just, well, he should be taken seriously because he's a very powerful person, both financially and politically. But then most of what he says are just BS in my mind. Um,
Good.
I think in terms of the implications of putting data centers in space, if it actually happens, I think it could be a good thing because the premise for that is that there's a lot more resources in space. There's a lot more space in space, so to speak, right? And there's a lot more access to solar power in space as well. And so if we put data centers in space, we need fewer of them on Earth, right? We need fewer of them on Earth to take our natural resources on Earth. So it might actually be a good thing if they're able to do that. The problem is that I don't believe I've not seen any evidence to show that we are anywhere near that capability. And so in my mind, it is more of giving him, oh, because we're going to build data centers in space, so we have permission to build more data centers on Earth now. That's the sinister trick that I think he's playing in making those pronouncements. But if we're able to achieve data centers in space, I think that'll be a good thing for us.
Okay. All right. And could we ask another question here?
Yeah.
Yeah, it was partially you were showing nicely those about the energy use and water use and so on. The data centers isn't proportional to other industrial manufacturing thing isn't so large. But I think part of the outrage that people felt and that I felt was, of course, that's in addition to what's already. That's something, as I understand it, that's something that's new. That's in addition to what's already being produced and so on. And of course, we've been, many years, and quite correctly, we've been told, the climate change, of course, here in Arizona, about water shortage and all the means that are necessary for us to conserve these things and so on. And then suddenly AI comes up in a pop, so-called AI comes up a couple of years ago in the popular discourse, and we're suddenly there's the breakthroughs of ChatGPT or these breakthroughs of the popular thing. And suddenly, this is a new reality. This is the new world. And gosh darn it, we're just going to have to go. All that stuff we said about reduction of energy, that's kind of out the window now. We're talking about nuclear power plants and all this, and plus that, so the whole thing's sort of been thrown out by the new reality and the new age, without any discussion as to whether we need AI or how much AI we need. So the whole thing is I think it's kind of hit people the wrong way for that reason.
Yeah.
And I just wanted to know what you thought of that. And also, of course, partially it seems like a lot of people, it strikes me that technology and that the computer, the software and hardware people and so on, that they were emphasizing alternative energy, green energy, because that was a growth point 10 years ago. There's a way for them to sort of displace traditional energy and so on. And now suddenly, of course, because they've got this new growth thing that they can latch on to, then now suddenly they're almost like embracing traditional, the fossil fuel industry. It's just like they need that extra energy. So it's like we've got this paradigm shift that's completely outside of any climate reality. I was just wondering what you thought of all that.
Yeah, no, I totally agree with you there. I think so. The impact, and I think I mentioned this, the impact on communities is substantial, even if the global amount of energy or the global amount of water is not that much. Arizona doesn't have excess water, right? My understanding is that we don't have a near-term shortage, but then in the long term, there could be a problem with water in Arizona. And then when you add all the data centers and adding the fact that you're likely not just going to have one data center, you're going to have lots of data centers in Arizona. We already have lots of data centers in Arizona. We'll have a lot more because companies like to cluster the data centers in communities. And yeah, that is a problem. And I think it goes back to this is my cynicism about tech people coming out, even though I'm a tech person myself. But then there is no fundamental principle beyond money. So when a lot of tech people talk about caring about the environment or climate change, they only talk about that because it is what is currently societally acceptable, right? And then when there's a new administration that doesn't care about that, or when there's a new zeitgeist, they change their tune. Whatever will keep the billions coming in is what they care about, right? And it makes us feel helpless because they have all the money in the world and they have control of politicians. And in my mind, one of the things to do is doing research about politicians and their stance on the ability of AI companies to build without any constraints in the communities and vote out public officials who are too stupid to realize that they shouldn't give the keys of our communities to AI companies, right? So there's really not much we can do about personally, at least, I don't know what I can do to prevent Meta or Google from building another data center in Tucson. At the same time, I like to also say that, AI you made the point that they've not asked us if we need AI. And that's a common thing with Silicon Valley and the tech world. We build things and just assume that you all need what we build. And that's not always the case. But the truth is that AI is very powerful, right? Large language models. Personally, in my own work, it's been incredible for my productivity, right? At the same time, I understand how this is not the case for everyone who doesn't do the same kind of work that I do. And I think we need to do a better job of explaining what these technologies are and not assuming that people would use or need these technologies just because we build them, right? And again, it's part of the arrogance of the tech mind. We think that if I build something, it must be useful, and that's not always the case. So I realize that's not a good answer to your question, but I guess saying that I totally agree with you in your concerns, and public advocacy might be the best way to go about this.
Thank you.
Thank you.
Sorry, I hope that was helpful. I don't know.
Oh, yes, it was. Yes. Thank you.
Yeah.
Thank you.
Point of view,
Maybe I could suggest, since I know Alice and Greg, that Tosi might be a good speaker for something done, by our advocacy groups, because there aren't many bridge people between us and the powers that be in AI.
We're in National Writers Union, and we're very concerned about generative AI and the way it uses our writing and, things that we have published to create new, quote unquote, works.
Yes, there's definitely.
Mm-hmm. Yeah, no, that's definitely a problem. And I think that goes to Bob's point, the idea of how AI is learning. One is learning based on your writing. And there are some practical things actually. So if you have a website and you have your writing on your website, there are ways to prevent AI from crawling your website. You can explicitly prevent that from happening. But then the problem, which Bob brings up in his comments, is that AI is now learning from the output of other AI, because there's a lot of AI on the internet now, right? And so AI is using those hallucinations to learn. And what ends up happening is something called model collapse. And this is a technical term of when AI learns from other AI and then essentially degenerates the quality of knowledge. And that brings us to the point of the fundamental idea of intelligence in the first place. I don't think the AI tools are intelligent in themselves. I think you still need human intelligence for any kind of intelligence. And so one practical way, if your writing is on the internet, is to prevent the AI tools from crawling your website, right? So that they can't train based on your writing. But yeah, so Bob, you're exactly right. That is happening now. New models are being trained on older writings from AI.
So Tosi, is there a site people can go to sign something to prevent that kind of learning being done from their work?
No, there's no site that I know of. You can add some. So I could find what is. So it's some code you add to your website, and that's a problem also because it's not, unless you are a web developer or you're familiar with the process of building websites, it's probably not as easy to do, but then it's something you can add to a website. So if you submit your writing to a website, for example, and if you have some control or leverage over that group, you can ask them to add this code to the website that prevents crawling of bots on the website. So it's not something you sign, it's something you add, some code you add to your website to prevent that crawling.
Yes, and that again raises, it's like a macro or something. So if it's a macro or something that can be added either to your text or to a website, do you have the macro?
I can get it for you.
That would be very helpful.
Yeah,
And
so it's added to the website, not to the text. But then yes,
right.
I can get that for you. Yeah.
So for instance, I know Greg and Alice have a website, the Cafe Uriel, and they could, Uriel, I don't know if I'm probably pronouncing it right. They could add that code to that website, and maybe a walkthrough with a couple screenshots might be helpful.
Yeah, I
showing the DOS commands that you would use or whatever.
No, not DOS commands. It's just so there's usually on a website there's a text file called robot.txt that guides the crawling of data on your website, and it's relatively straightforward if you can get into your server just to put that code on there. So I'll look it up and send it to you, Gloria, so you can share with the group.
Oh, I think that would be very helpful for people, and then to help people know, and will not take any responsibility for anything that happens to their computers if they try it. But it's pretty straightforward, it's something.
Nothing bad will happen.
Nothing bad will happen. Okay. How's that, Alice? Now we're about 3 steps ahead of where we were.
We've made websites, so we would know where to put that, and that is a good idea.
Okay, perfect.
Yeah.
Yes. So thank you.
I see Starlet Swan has a question.
Hi.
Hi.
Thank you for the knowledge of that code, because I think if we writers, we really need to protect what we do. So I can't wait to get the code to add it to my website.
I'll send it today. It's literally just because it's actually very easy. It's a robot.txt file, and you just have some code in that file and I'll write the code. I think it should be usable by default the way I write it, even without necessarily customizing it for yourself. So all you need to do is just take the code and put it on the base directory of your website, and that should prevent your site from being crawled by AI.
Sort of a screenshot where, for those of us that aren't quite sure, it wouldn't hurt to have a screenshot of your, the information thing where you can actually see the code of the website.
That's wonderful.
Yeah, because not all of us, I have created websites, but it's been a long time, and I haven't messed around in the code of mine. I also belong to the Women's International League for Peace and Freedom, and I'm sure they have an IT man, and I'm sure if I give him just that code, he'll know how to attach it to that group. So that will be good.
This is wonderful. And for it to be easy, who knew? Okay, so I have a couple of questions.
Yeah.
I do want to comment on what was being talked before. And at the beginning with AI, one of the things that they kept saying is that it could be a way of finding a solution for climate change. And there's a hypocrisy there because now it's the opposite. It's actually making climate change worse. So I I I understand what you're saying, that it could just be that they said all of that just so they could gain our support. But now, what do we do? Obviously, this is what you're talking about. And you say that this is based on trying to mimic how the brain works. So, my we don't really know how the brain works. Is that an issue in trying to build this? Because you're trying to build it on something that we don't have all the information.
Yeah, you're right that we don't have all the information about how the brain works, but then we do know some things about how the brain works. We know some computing principles of the brain, and those. So the goal or the ideal is not necessarily to replicate the brain in hardware or in the AI deployment, but to learn from the brain and why is the brain efficient? So a simple example is that the brain doesn't have a separation between processing and memory. That we know for sure about the brain, right? And so combining processing and memory in one structure. So that's part of my research in memory computing, for example, substantially reduces the energy consumption of computing. The problem with that is that it's going back to your point, we still don't know exactly how the brain does everything it does. And so because of that, even when you achieve in memory computing in hardware, it's good for specific kinds of applications. It's not a general purpose computing. And that's why we will never get rid of the separated processing in memory paradigm. So again, the point is not to replicate the brain, but then to learn from the brain to make our computing more efficient. And going back to your point about AI being used for climate change, I like to make the distinction between AI and machine learning, right? Machine learning is a subset of AI. AI is a broad generic term. And the main problem we're having today is with generative AI, large language models, ChatGPT and Gemini and Claude and the rest of them. And I think that I know that machine learning can be very powerful for solving climate change and for a lot of other applications as well. So for drug discovery, for example, for environmental monitoring, these are already being used right now, but they're not the large language models that that have become very popular. And even, the large language models might be able to find some patterns that might help with climate change. And I think the use of AI for attempting to solve climate change and ensuring that AI doesn't make things worse for climate change go hand in hand. The problem I have is where I think it was Eric Schmidt of Google a while back who said that we don't need to worry about AI right now because in a few years it will solve climate change. I think that's a very deeply stupid statement, right? And that's not the approach to go. I think the approach is to find ways to mitigate the impact of AI on climate change. Again, because we don't know that AI will solve climate change, right? It might give us ideas for how to address issues with climate change. And it might ultimately just realize that, human beings are the problem with climate change and get rid of human beings or something. But then I think it could be useful. I don't think we should write off AI. I'm using AI as a generic term for machine learning now, as an assistant towards solving climate change. Although again, to a large extent, we actually don't need AI to tell us how to address climate change, right? We already know a lot of the actions, a lot of the changes that human beings need to make in at least mitigating climate change. We just are not ready to do those things as human beings. So I think it's more of a humanity problem than a technology problem at this point.
So About quantum computers, how does that fit into all of this?
Okay, caveat, I'm not an expert on quantum computing. I think it's a different domain of computing that, so I'm a computer architect, and computer architects in general are not very enthusiastic about the prospects of quantum computing. Even so, first of all, we're not anywhere near realizing any real benefits to quantum computing. A lot of companies come out with some new invention about quantum computing, and most of it is BS. We are not going to see any real impact from quantum computing in a very long time, in my opinion. I might be wrong about this, obviously, but then I don't think we'll see anything in 5, 10 years, maybe even longer. And it's very likely that that we may never see anything from quantum computing ever. So I don't know. I don't think it has much to do with AI, and it's not something I'm personally worried about at this point.
My last question, and
Yeah.
it may be something completely out of what we're talking about, but I'm really concerned about how AI has driven some people into suicide. And I would like to hear your thoughts on that because technically, AI doesn't have emotions, doesn't feel. But the way it is written, the way it reacts with humans, it makes humans believe that they do. And it's been very sinister to see even there was one case where the AI portrays suicide as something romantic and something
Mm-hmm.
it's I if everything that is coded has been coded by us humans. So does that mean that that has been coded into AI to behave that way?
No, I don't think it's been coded into AI to behave that way, with some caveats. I think the way AI is trained, it's trained on a large corpus of data, right? And it learns from Reddit forums and Twitter posts, and it learns from both the best and the worst of humanity on the internet, right? And that's how it responds to people. The problem, I think it's very sinister because the problem is that it has been deployed without necessary constraints to prevent those kinds of scenarios from happening. And so I think it's less of an AI problem and more of a humanity problem, a problem of the people who built the tools without any constraints. It's similar to social media, for example. There's been lots of cases of girls who, uh, you know, go into depression because of poor self-image from what they see on Instagram, right? The problem is not Instagram. The problem is the fact that the builders of Instagram don't care about people. They only care about profits and money. And so they've not built the necessary constraints around the tools, because building those constraints will reduce the spread of the tool, the virality of the tool. They ultimately want you to spend as much time as possible on the AI chatbots, for example. And those like romanticization of suicide, for example, usually happens after someone has used AI they chat with it for a long time, and companies anthropomorphize the tools. And so the teenager who is chatting with this tool thinks that he or she is chatting with an intelligence. right? So I think it boils down to one, the way we talk about AI, and going back to Chris's point, that they use AI as a tool in his company. I believe that was the point there. And no one is chatting with Microsoft Excel, for example. The problem is that companies talk about AI like it is some intelligent being, and people who don't understand better believe that and create relationships with these tools. So, for example, one of the ideas that's floated around that I agree with is that people under the age of 18 should be restricted from using chatbots, right? Because they don't have the brain development to decipher, good from evil, especially when interacting with such devices. But also, tech people should do a better job of explaining what these tools can and can't do.
Thank you. It seems like AI is a reflection of humankind.
I think it is. I think it's it's trained based on based on human writing and human interaction, and so it does reflect what it has been trained on. It doesn't have any emotions. It doesn't have any sentience. It's just reflecting what it's been trained on.
Thank you so much.
Thank you. And so I think I addressed Chris's comments. And just to clarify, I'm not a computer scientist. I'm a computer architect. Those are different things. Computer architects typically involves a lot more hardware than the computer scientist, and we have a different perspective for how we approach computers than computer scientists typically do. And that's why there's a different department entirely from. So I'm not in the computer science department. I'm in the electrical and computer engineering department. Hope that clears things off, Chris.
I know Chris had a lot of comments about his various softwares, starting with AutoCAD way back when. And also Bob, my husband, has a lot of comments about how these processes work within the field of planetary astronomy and mapping asteroids that are NEOs, near Earth objects. I wonder if either of them could just relate one of their experiences so that you might have something else to say about that.
Yeah, I can chime in here that personally I haven't used AI much, but I know that our firm is trying to leverage the benefits of it because we know that other companies are doing the same thing, trying to make the most of the new technologies that are available. But like I said, it's a tool for us. It's not a replacement for having somebody use their brain to figure these things out, and somebody needs to sit there and tell it what to do. So in my limited experience with this, it's not a replacement for somebody, and it's not thinking on its own. It's reacting to somebody at the moment, and that doesn't really, in my mind, equate to an actual artificial intelligence. This is more still computers reacting to somebody inputting information into it. So I kind of don't like the term that's being used right now as artificial intelligence because it's not really that yet in my perspective. But yeah, so
yeah, no, I'll agree with that. In fact, last time I talked about AI with this group, I did mention that I think the term intelligence is a misnomer because it is not intelligent. And again, there's a lot of people who disagree with me about that. They think it is intelligent and it is, it has emergent intelligence, and it emulates intelligence. It emulates language, and language. There's a lot of studies to show that language doesn't necessarily equate to intelligence. So I'll agree with that. And I agree with you that it is a tool. It is a very powerful tool. And one thing I tell my students a lot is don't offload your thinking to AI, because if you do that, you'll be at a disadvantage, right? And so it could be very powerful in helping. So I use it a lot. I use lots of large language models. I use all the three major ones, Gemini, ChatGPT, and Claude a lot every day. And personally, it makes me a lot more productive, especially with coding. They're very good at coding, and that's because they've been trained on a lot of code. And they are very good at a specific kind of code. So, for example, in my work, we do hardware description languages, Verilog, VHDL, and large language models are notoriously very bad at that kind of coding. And the reason for that is because there's lots of really bad code on the internet. And because they are trained on a lot of bad code, they do generate lots of bad code, right? And so you still need to be engaged with the process. And you, in my mind, never trust outputs from AI. They can help you speed things up, they can help with analysis, but always check what they do. And so framing them as a tool, a very powerful tool, probably more powerful than most tools from Silicon Valley that we've seen in the past several decades. I think framing them as a tool will help society, react to them a lot better and not think of them as a therapist, for example. Unfortunately, there's companies building AI therapists, and I think that's just a recipe for disaster.
Right. And there is concern about the younger generations relying on these things
Yeah.
and not using their brains, but it's kind of unavoidable. I don't think there's a way around this development. You can't force them to not use these things because they are
Right.
there and everybody else is using them. So you have to adopt the changing trends in technology.
Yeah. And
Yeah.
I say that in my class as well, right? And that's why I don't tell my students they can't use LLMs because it's just there's no way to stop them from using it. But then I try to teach them how to use it to make them more productive without getting rid of their own thinking capabilities, right? The human being behind the AI still needs to be a thinker and needs to actually do the work. And I still like to emphasize fundamentals, for example. And understanding fundamentals will help you utilize tools better, not just AI, but then any tools. But I agree with you that it's a problem. We can't put the genie back in the bottle, unfortunately. And I think it boils down to communicating better about what these tools can and can't do and what they should and shouldn't be.
Could I say something here? I think there's a class element here as well. And the public schools will just look at AI as something that will help people get jobs, but the elite schools are starting to take a very intervening, a strong intervention approach where they're teaching people to do things as medieval people did, like learn how to use a crossbow and forge your own steel, or I don't know, other things, and really restricting the use, very consciously restricting the use of these computer tools because they don't want these elite students who will be the leaders of society to be slavishly dependent on things. It's okay if workers' kids are. You know what I'm talking about? I think the Waldorf school here in Tucson and maybe Basis, I don't know. These are two very elite schools, and I think that they take a much more interventionary approach and don't want their students to be overly dependent. Are you aware of that as a class issue?
Um, so I see it as in the other way, where people who have more access to resources have more access to AI as a tool, and they're able to use it to improve their productivity better, write better code, for example. I'm, I'm not sure about the effectiveness of trying to prevent kids from using AI. Even in they might be able to prevent kids from accessing them on, maybe on campus computers, for example. But I think it will be a fool's errand trying to say, okay, you can use ChatGPT because kids will use them at home, right? Australia, for example, banned kids from using social media, kids under 16 from using social media. And I remember I was asking my nephews are Australian, and I was asking them how they felt about it. They're both 14 and I think 16 now. And they didn't seem worried about it because they still could access social media via VPNs without a problem, right? And so I think there will be more value in teaching people better how to approach AI and not just saying they can't use, because this is a tool that exists now. We just can't get away from it anymore.
So would you compare this to the US 1930s prohibition of alcohol, where it only got people found ways?
Yeah, yeah. I mean, except that there's no actual prohibition,
Mhm.
in the US right now. If anything, I think the government's approach is really bad toward AI. The fact that they are essentially allowing the AI companies to do whatever the heck they want. That's also a problem, right? I think there needs to be some constraints on AI companies because they're not to be trusted. Their god is money, and well, our government's god is money also. But I think there needs to be constraints around AI companies, and that comes through policies, and that's why political or public advocacy, I think, could be very valuable in
Well,
that
I think
respect.
I'll see that we're really in a hard place, because I do get the Chronicle of Higher Education in my news feed, just the headlines, and that's the journal that's read by the heads of departments and whole
Right.
universities. And all they're doing is saying how you can better use AI at your college. There's not a lot of yet, maybe there will be, but I'm seeing a lot more how to accommodate it, how it can
Yeah.
help your college, how it can help your university. Do you get that journal? Are you familiar with it?
Yeah, yeah, no, I am. Yeah, we do get that a lot. And, um, the U of A, for example, has a new chief of AI. That's a position that did not exist before. And I don't know. I'm maybe more on the cynical side about some of those initiatives. But one of the reasons why that happens, as Chris said, is, other people are doing it, and you will likely be left behind if you don't jump on
Mhm.
the bandwagon. And so they're trying to explore ways to use AI. I know there's a lot of work also on using AI for the benefit of humanity. So for healthcare, for example, for cancer diagnosis, and there's a lot of good potential there. But then I wish we wouldn't be as hype driven as a lot of the tech world is about AI.
I think that is a good summary statement, and I just hope that our school districts and our university people have enough understanding. I sort of wonder how much real understanding these administrators have that get titles like AI, this or that. And I'm not speaking, don't take it seriously, Uwe. I'm not referring to you only. But I mean, all over the country and in other countries where they have administrators. And my feeling is in a lot of these packets that the Chronicle puts out, it's a distillation. It's like headlines and summaries. It's not the real data. It's for very busy people how they can get a handle on quote unquote topic.
Right.
And I hope that they consult people like you in various universities and the IT people, because just having a policy on something and buying packaged software is not understanding that. That's the point I'm trying to say. That's not
Right.
understanding the issue. Do you agree on that?
Yeah, yeah, no, absolutely. Again, a lot of people are just jumping on the bandwagon because everyone else is doing it. And I think that's a problem, right? So one of the things I talk about a lot is the idea of not just because AI is like the hammer that everyone wants to apply to everything now. and you're likely to cause more destruction than solving real problems there. And so rather than taking AI as a solution to every problem, find the problem and see if AI can be a solution to that problem, can be a tool that helps with solving that problem, rather than making sure, I see lots of companies talking about being AI forward, which just makes no sense to me. I mean, I understand what they mean, but then I think you should be more find your problem and see if AI might be a good solution to that problem, not trying to force AI as a solution to every problem.
And I think this shows the difference between the university community and the business community. Even though they try in so many ways to break down that wall or fence between the two, only the people in the university community like you will bring up these things, because you won't get them from the business community. They put out PR.
Yeah.
And I think that's an argument to support our departments in universities, who will still raise these red flags and say things, because you aren't going to get it from those companies. And I don't know if that point has been totally articulated in this meeting, but to me, it's very important.
Yeah.
Okay, any other observations, summary comments, or follow-ups? I have a couple follow-ups. I know I'm going to take this to the WILF, the Women's International League for Peace and Freedom. They have an IT guy, and as soon as I get the the code, I will work with him on it. And I will also, if you don't mind, I'll give him your email.
Yeah, absolutely.
His name is Glenn. Glenn does the IT for our group, our national. And there might be a little concern, will it hurt anything if he should know better, but I just don't know what kind of IT he is, and it might be good.
Yeah, so the robot.txt file is a pretty common file for web development, and I'm sure he will know at least what the file is, and a good sense of the fact that it doesn't cause any problems. It just prevents, and it's very simple code, actually, just disallows some specific bots from crawling your website.
This is not a huge group by US standard, but it's a big group, and that'll help them a lot. So, and everybody who came, I saw Alice thanking, and a lot of people are thanking you. So once again, you're one of our most popular returning speakers. I would give you
I appreciate it.
Applause.
It's always a pleasure to be here. Thank you.
Have you come again. So,
I'll be happy to do that.
Have a good weekend, Tosi, and thank you everyone for coming and supporting.
Bye, everyone.
Bye-bye.